Welcome to Newstead Test 10 Non-Verbal Subtest 1. First instruction, you have to turn the volume all the way up, then you can hear me clearly. Do it now as I lean back. All these questions are the most unlike the figures. 6 minutes for 12 questions. You can play along with me or you can just look at me explaining these questions. If you're watching this video, you might have done this already. So here we go. Which figure is most unlike the other four and mark its letter on the sheet? Here we go. There are so many shapes, inside and outside. What do we do? Let's count. Here we go. So, outer shape. You can write it with me or pause the video now, have a go, then we watch the rest of the video. First one, count. 8, 4, 5, 6, 7. Okay, now we count the inner. We count inside, of course. How many triangles? 6. 6. 6. 6. 6. Okay, nothing to say there. Right, what else to say? Well, it's nothing to do with inside, outer. Oh my gosh, there could be something else. How do I know? Because I looked at the mark scheme just to prepare. I was kind of thinking it was the layout inside, but I still couldn't see it. Here's a clue. Look at the layout of the 6 triangles. Just pick 2. Can you see they're really close together? Really close together. And the entire layout is really the same. Close together, close together. So what we're saying, well, they're quite far apart. The setup is a bit different. C is the answer. That's such a tough question. It's ridiculous. Next. Question 2. Now's your chance to pause the video now to have a go. I'll give you 5 seconds, or you can just do it. Or you can just watch me explain it. 5 seconds. So a quick glance at all of these shapes, they all look the same. Circle, triangle here. Now because of that, maybe they all are actually the same except one of them. Now, in order to get this right, maybe we just pick one bit to look at. Can you see that circle and that red square? Well, just flip it around. I'm going to turn this dude round so it will be here. It will be here, and really they're the same. Now we compare A and C. I turn this, spin this round a bit. Maybe if I copy this just to help. That's the beautiful thing about using this software. Can you see I spin it around, it looks exactly the same. So what is William saying so far? Well, A, B and C are exactly the same. Alright, let's spin it round to get D. I'm going to spin this dude round, rotate right, and they look the same. So there we go, E is the answer. I just want to show it properly. If I spin it round, let's go left. Oops, left, left. Here, they are not quite the same, because that triangle is just the other way, and also the line is just going, well, a different direction. So that's a really cool question. Please note, I've seen this so many times where they all kind of look the same, and guess what? They are the same, except for one of them. So remember that pattern. I bet it'll come up on the real day. Next. Question 3. Okay, if we quickly glance at all of them, so straight away they're all the same kind of pattern, so we must count. And I'm going to give you a clue, they're actually all 7. I'm going to save you time because I've just done it. Right, next thing to count. I was thinking the number on the long diagonal. Can you see here? That one has 2. Then that one, 1, 0, 3, and then 2. So they're actually all different. Okay, that doesn't help. Next bit. I was thinking the other long diagonal. That's 3. 1, 4, 2, 3. 4 for the last one. It doesn't matter. They're all different. And now, I got really angry when I first did this question just 30 seconds ago. Now I saw another pattern. I'm quite pleased with this, but it's so tough. I can't believe this is even a question. I was going for long diagonal. You need to go each row. How about the top row? Can you see 1? 1 in the top row for every choice. And second row, 1 as well. 1, third, 1. There's always 1 in each row. That is basically ridiculous, but there must be something to consider. And if we keep going 1, 1, 1, 1, 1 all the way, and there's a row. Oh my gosh, there's a row where there's 2. That's basically so tough to spot. I was quite pleased with myself because I've never seen this question before, but oh my gosh, there's 1 in each row, except that one. Because we keep going across like this, and then there's 2 in that row. Wow, what a question. Next, number 4. question 4, just had to check the mark scheme just in case. Alright, number 4, here we go. So lots of black and white shapes, just going to save you time. It's not going to be how many white circles or black circles. Alright, let's look at the type of shapes. That might help today. Look at that. It's a regular square and regular pentagon. Okay, well, so what? This one is regular heptagon, regular hexagon. Well, so what? Regular here, here, and here. So what is William trying to say? Every time I put a blue tick, can you notice inside a regular shape, what color is the circle? It is white. So what are we saying? The other case, if it's an irregular triangle, we got black circle inside. Irregular here, here, here as well, here, here as well. So overall the answer is B, because that's the one where it doesn't have. What a tough question. Write it with me. Had to check the mark scheme just when presenting this video. You are joking. So regular circles, regular shapes have white. Irregular have black inside, but then B is the wrong one, because if we look at that one, black circle inside is a regular triangle. It's your equilateral triangle. Wow, that's one of the toughest questions I've ever seen. Next. So this is called a conditional statement. If this one, then something else, white. If this, then something else. There we go. Next, question 5. 6 minutes in, let's hurry up. Okay, so when I look at these donuts, these ovals, my first instinct is we just count each section. There might be some connection there. Let's do it together. So 6, 3, 2, 5, 5, 1. Okay, so what? Now already I'm thinking, well, maybe it's the total. If we add up all the numbers, maybe it's the same total. It could be some connection, or it might be something else. Here we go. 4, 2, 2. This one. 7, 4, 2. And then here 1, 2, 3, 4, 5, 6, 6, 6, 1. Okay, so we've got so many random numbers. Maybe we add them all up. I'm just going to show you that just in case it might be a reason for a future question. Let's put the total here. Total here, quickly add it up. We've got 11 here, 11 already looking good. We will see, but this one is 8. Already I'm thinking maybe odd or even number. That could be a connection here. 7 plus 4 here. We've got 13. And then that one is 13. Okay, so really based on this, the answer should be... the answer should be C. Brilliant. You see, they can't do this because in the mark scheme, because I've checked it when presenting this, they went for something else. No, they can't do this. All of them are odd, except that one. So C could have been the reason. Now, here's what they said. How do we get 2 using 3 and 6? We divide. How do we get 1 using 5 and 5? Divide. Division. Left, divide, middle equals the right one. Here, it doesn't work. Doesn't work. This one works. 6 divides 6 equals 1. You are joking. So really, in my opinion, it is a bad question because there's another reason. There's another reason. So it could have been C because it was the even one, but not today. In the mark scheme, they went with D. So bad question. Next. 8 minutes in. Okay, we got a few more. That's it. Right, looking at question 6. Shapes, count. No choice, mate. No choice. So outer shape, count with me. Count with me here. Then what is that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 9. I think that's 10. 8, 6. Those ones you might have seen so often. I can see those straight away. 8, 6 for the final 2. Now, when you look at these blocks, you might be thinking counting every square. Absolutely not. I mean, they have just made for some of them bold. Bold, so count. 1, 2, 3, 4, 5, 6. The reason they are bold is for you to stand out. It's for the squares to stand out. And then, of course, you count. What else do you do, man? What else do you do? Count. 1, 2, 3, 4, 5, 6, 7, 8. Already there's a connection. Can you see from outer to bold? Well, it's just one less. I'm hoping that is it, or else, oh dear me, too much work. Now this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good stuff. 2, 3, 4, 7, I think. 1, 2, 3, 4, 5, 6, 7. And then the last one, 1, 2, 3, 4. Good stuff. There we go. Right, the reason nearby to go from the top to from outer to bold, it will be -1, but this one is -2. E is the answer. Next. Question 7, it looks like it gives you a headache. Now, I've seen these questions enough times. You might be thinking, is the number of times they cross? Maybe. or total number of lines. I'm going to save you the hassle. It's not going to be total number of lines. Look at this. This one, E has so much more, so many more lines than B. And that can't be the reason. So I've seen lots of these before. You need to break it down. It could be vertical or horizontal, because that's how to group these kind of lines. So let's quickly do it. We're good. Vertical here. That just means going down. Count with me. 1, 2, 3. Vertical going down 2. Let's move this dude up. Here. 1, 2, 3, 4. 1, 2, 3, 4. And here 1, 2, 3, 4, 5. Horizontal. And 2, 1. 2, 3. 1, 2, 3, 4. Good. Okay, we're going from top. That one looks like a -1. Hey, pretty similar to this one. Hey, at least they're being nice in that respect. -1 for all of them except C. There we go. 2. So C is the answer. Fantastic question. Next. Okay, we're 11 minutes in. Let's hurry up. Question 8. When I first saw this, I thought, yeah, it's just a headache. Now, this is a Newstead Test 10 question. It's not just going to be, oh, the number of black, number of white, too easy. No, I'm going to save you time. Is actually looking at one of the rows or one of the columns. Now, why is William giving you this shortcut? Because I'm just telling you, it's a Newstead question. It'll be tough. If you look at the top row, it's not that. Top row, we got 2, 3, 2, 3, 2. No, but next row, 2, 1, 1, 1, 2. Next row, 2, 3, 2, 3, 2. Next one, 2, 1, 3, 1, 2. No, there's nothing in common. Now we look at each column. First one, 2, 2, 2, 2, 2. Nope. Second column, 2, 2, 2, 2, 2. I keep saying 2. No, next one, number 3, 2, 2, 2, 2, 2. And now 1, 2, 2, 2, 2, 2. Oh, you're joking. You're joking. Except it's not even that. You're joking me. So here is actually the exact layout. Can't believe it. What a super tough question. Hey, that's part of Newstead. I'm just going to give you the big clue. It's actually the third column. I'm actually quite angry how tough this is. A and B is not the answer, because if we look at column 3, the exact same layout. If you look at C, it's actually a bit different. If you look at D, we got same layout as A and B, and same here as well. Almost impossible to swap. So very important test strategy. If you can't see it within half a minute, within 30 seconds, it's so important you move on. Just quickly pick C, D, or E. That's why I tell my students, because C, D, or E are some of the final options. So it might be the answer, because answers tend to be nearer the end. Next, 4 more questions, that's it. Question 9. Okay, now we're going from one shape to another. That is just a gut instinct. Why? Because you see the top shape and the bottom shape, they basically look the same. Alright, we go from this to that. It looks like we turn anti here, anti. We're going that pentagon to that one, yeah, anti as well. Oh gosh, they're basically all the same. That's not true. If you look at the top shape, it kind of looks like a squash version. So not only am I going to turn it anti-clockwise, I'm going to stretch it out. Turn this round, stretch it out. It will be a long one. Turn this pentagon, this flat pancake, turn it round, stretch it out. Looks like C. D is basically the same shape, so none of that. And this triangle, you turn it round, stretch it out a little bit, E. So really, D is the answer, because when you turn it anti-clockwise, you don't stretch it. Next, number 10. Are they being nice with this one? Yeah, absolutely, because there's a number on the bottom, so that must be part of it. And now we might as well just count. We might as well just count. So what are we saying? Well, circles. Why not? Write it with me. Circles. How many in total? 3. I bet the total matters, because we've got the circles and then the shape inside. That might be enough. This one. 5. Looking good already, because 3 and 5 part of the times table for the number on bottom. I'm hoping that'll be it. 4, 3, and then 4. Okay. Well, that's not times. It might be E. Who knows, mate? Who knows? Let's count. Number of sides of the shape in the middle. Here we go. 3. 5. 6. 4. Okay, and now we got a connection. Fantastic, because I mean, if you got 3 and 3, we get 9. We multiply it, we get 5 and 3, we get 15. What else to do, mate? What else to do? So 4 times 5 is 20, and then same here. 3 times 6 is 18, and then it didn't work. 4 times 4 is 16. That's what it should have been, but it isn't, so E is the answer. 2 more questions. That is it. Question 11, 12, 2 more questions, then you deserve a break. Here we go. So when I first saw this question, I was prepared to just, well, throw it out. Just put it in a recycling bin. What on earth is this gobbledygook? If that is even a word, what is this? I just can't see a way to bring meaning to it. I mean, first of all, I thought it was like A because there's a gap, and I thought all of these are connected, but then there's a gap there. So, whenever you see a random question like this, all these blobs and curves, well, you ask yourself what on earth you're doing, but really, to bring some order to it, you think symmetry, because it's an odd one out question. Line of symmetry might be good enough. Here, symmetrical. B, don't think so. C looks good. D and E, like there. So there we go, B is the answer. All right, one more question, job done. So, line of symmetry, remember that. Final question, you deserve a break. Number 12. Okay, lots of shapes, but they kind of look regular, just to go from one to the other. Here we go. Thin rectangle, then a bit bigger, then bigger, and then the biggest. So what are we saying? Maybe something to do with symmetry. To go from one to the other, here to here to here to there. It looks like we keep rotating clockwise. Dun 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 dun, yeah. Ovals, yeah. Keep turning round, turning, so then it's on. So it didn't really work. It didn't really work to go from one shape to another. Hang on, doesn't E looks a bit funny. I think there could be 2 answers. I'll just check pretty soon, because that one doesn't quite look the same. Ah, maybe a second shape is the same. Hang on. Dun, dun. 1, 2, 3, 4, 5, 6. They're all hexagons here. Yeah, they're all... There, fine, ignore me. It's hexagons here, dun 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 dun. They're all triangles, pentagons, 5 side. You've got your oval, 1 side, and then rectangles, 4 side. Okay, I can just about see it, because when we look at all these random shapes, it's about layering. Now, the bit that stands out to me is that one. The second one is on top of the third one. Like here, the second oval's on top of the third. Second pentagon on top, and here, can you see it's behind? You're joking, that's so tricky. And this one's on top, so there we go. D's the answer, because that's the one that's not on top. He's behind the third triangle. So thank you so much for sticking with me all the way until the end. 17 minutes, job done. So my normal way to end the video. In the top left corner will be another suitable video on this channel, and then bottom left corner, same thing. Thank you so much. You deserve a break. I'll see you next time.